All right, so this starts chapter 6, 6-1, operations on functions. This is a lot of normal stuff, okay, stuff you've kind of already seen, stuff we've already done a little bit. So it's just different ways to me asking it, okay, but as far as like operations and stuff go, we're not doing anything new. Okay, it's just going to be how I present it, the notation you talk about it in. That's the new stuff. All right, so here is basically your, I don't want to say Bible, but this is your how-to of everything. So what we're going to start doing is we're going to start adding functions, subtracting functions, multiplying functions, dividing functions together. Okay, so for example, whenever we're going to add functions, now this is the part I would need everybody's ears open for. Notation is going to be like this. Okay, that's the way it's going to be presented to you. F plus g of x. Okay, that's the way you say it. It is not f plus g times x. This is function notation, so this x is just there. What it really means to do is what's to the right. Take f of x, g of x, add them together. Okay? It does not mean to multiply, add them first and then multiply them by an extra x. Not what it means. So what I'm saying for all four of these is this. They will be given to you in this notation. You need to translate it to that notation in order to actually do the problem. Okay, makes sense so far? So for addition, you're going to just take the two functions, add them together. Okay, if you look to the right, there's a cute little example. It says f of x is 2x, g of x is negative x plus 5. So you got 2x plus negative x plus 5, combine like terms, x plus 5. Okay? What we're doing today operation-wise is like terms and multiplying. That's it. Okay? That's it. That's all we're doing today. It's just how it's done. That's the new stuff, okay? Subtraction, and these go the same down the line, right? You have f minus g of x is the same thing as doing f of x minus g of x. So the same example, 2x minus g of x, which is negative x plus 5, distribute the negative like terms, 3x minus 5. All right, multiplication, same way, f times g of x equals f of x times g of x, so they distribute the 2x through to get this. The weird one's division. Okay, and this is where we start changing up and start growing up a little bit, where we have to talk about our domains and ranges. Division, you have f divided by g of x to translate to f of x over g of x, and then they throw this little nugget in, g of x cannot equal 0. Why can't it? Because you can't divide by 0. Okay? And remember what functions are. They are quantities that you are plugging numbers into and getting numbers out. Well, if you plug, for example, 5 in over here, what are you going to get out? If you do this in a calculator and do negative 5 plus 5 and then try to do 10 divided by 0, your calculator is going to tell you what? Error. We can't have errors. So the special thing with division is we have to look at what the denominator cannot be. And we have to state that now. Okay, so we have to make that switch just a little bit. Okay? Okay, so given f of x equals x squared minus 4, and g of x equals 2x plus 1, find each function. Indicate any restrictions in the domain or range. That's your fancy talk for division. Okay, that's what that means. That means find what the denominator cannot be. Okay, so if you're not dividing, it doesn't mean anything to you. Okay, like I said last slide, the biggest thing is making sure you understand what this means to actually do. Okay, instead of it being f plus g of x, I rewrite it as my normal function notation, f of x plus g of x. Because once I do that, you basically turn it into a substitution problem. Okay? That's basically what you do. What's f of x? X squared minus 4. What's g of x? 2x plus 1. So you're just going to plug those two quantities in. Okay, and when you plug in, don't forget parentheses. Okay, so x squared minus 4 plus 2x plus 1. Green. No. And then you do what? Like terms. Okay, so x squared plus 2x. Negative 4 plus 1 gives you negative 3. And you're done. That's it. Obviously. Jazz?
So like you can't, so like you do anything possibly now, like exponents.
No. These will all be positive exponents. Because these will actually start off as functions that are actually functions, you know, that you can graph at the side. So there won't be any negative exponents. Not a lot of crazy stuff. Okay? Chamberlain?
So you won't be pulling like that, like basically.
Yeah, that's it. You don't need to factor that or nothing. Just add them together and be done with it.
So if like you know how you just on x squared and 2x down because they didn't
Having like terms. Right.
Okay.
Okay. Easy. For plus, that's fine. Okay. But whenever you go to minus, when you do the subtraction, okay, you see what I'm saying with that? Because what are you going to end up having to do? Oops. Distribute that negative through, okay? Okay, so my recommendation, obviously with addition, it's not a big deal. Subtraction, though, you definitely need them. Multiplication, you definitely need them. Parentheses around your terms, okay? Because here we have to do what with this negative sign right here? Distribute it through. Okay, so you get x squared minus 4, minus 2x minus 1, and then you like terms. So x squared minus 2x minus 5. Okay, so given f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4, find each function. Indicate any restrictions in the domain and range. So now we're going to do our multiplication, and we're going to do our division. Okay, once again, bless you, make sure you write. And the book does it, the paper or the worksheet generator will do it, your test will do it, the ACTs will do it, so that's why I do it. They give it to you in this notation. This notation doesn't help you with what you actually need to do. So make sure you know how to switch that from that to this. Okay? Ron?
Would this be on the ACT?
Yeah, it could be. Possibly. They like functions on the ACT. Yeah, definitely could be there. Okay? Jazz? Yeah, you could have F, G, H. Those are typically your big three that they'll do these with.
No, I mean like more than two.
You could. You could.
Are you gonna have a one?
Probably not. So F is x squared plus 7x plus 12. And we're multiplying that with G, which is 3x minus 4. Which turns into a trinomial times a binomial, which means you have to multiply that out like last chapter. Okay, so I'm going to kind of do that a little quick. So x squared through the binomial gives you 3x to the third minus 4x squared. 7x through the binomial gives you 21x squared minus 28x. 12 through the binomial gives you 36x minus 48. Last step. I like terms. So 3x to the third.
Wait, how did you get from there to there?
Multiplied.
How did you get
So what, 3x cubed plus what, 17x squared? Plus what, 8x? Minus 48. Okay, good. Now, your division, that's the one that's going to be kind of new, kind of different, all right? It's easy at first, okay? Because you basically take f, you take g, you put f on top of g. So x squared plus 7x plus 12 divided by 3x minus 4. And that's half of it, right there, okay? You don't have to do like any crazy synthetic division or long division or anything like that. You just write top over bottom, be done. Okay, but remember what you have to do now. Since we're talking about new functions, we have to figure out what number we cannot plug into the denominator. There's two ways you can go about this. Way number one, look at it and figure it out. Okay? Because sometimes it's just going to be, x plus 7 down here. In that case, what makes that 0? If x plus 7 is down here, what number would make that 0? Negative 7. That's a single equation. You guys are juniors. I expect you guys to know how to do that without writing it out. Okay? A two-step equation, to be honest, I kind of expect you guys to know how to do that. Yeah. Okay? But if you don't, your other option is this. Just take the denominator, set it equal to 0, and solve it. Okay? Because that's what you want to know, what x cannot be. So what x equals 0, if you do it this way, I'll understand you're finding what number it cannot be. So your first step is going to be to add 4 and then divide by 3. So both of these are your answer on division. Okay, division's different. The other new topic is, or the new operation basically, is what the rest of this lesson is about. The new operation is called a composition of functions. Okay? It's called basically a composite function. The words are a little iffy. The model is iffy. What you need to know, and what we're going to make sense with the model, is right here. Okay? A couple of things, all right, as you look through here. Composition of functions, key concepts. Suppose f and g are functions. Okay, so f and g are just normal functions. Here's where this gets really wordy. Such that the range of g is a subset of the domain of f. Yeah, exactly. Basically, here's what it's saying. Well, these domain means what? Domain are your x's. Okay? So the domain of your g function, you get is right here. You plug it in. There's a set of numbers. There'd be a group of numbers that are in both the range of g, which are your g's what? After x goes y. That's also in the domain of f, which is your f's. Before y goes x. Okay? Then it comes out, spits out as a number that is in your range of f, which is your f's y's. Boiling it down further, you're going to take one of g's x's and get a y. Right? You plug in x's, you get y's out. Everybody remember that? Yes? No? Maybe? I don't know. Wasn't listening to Mormon. Couldn't care less. Okay? Yeah? You plug in x's, you get y's out. So you're going to take an x, plug it into g, get a y out. That y of g is going to turn into an f, or an x in your f, which turns into your y in your f. A lot of letters going on, right? It's a little easier than that once you actually see it, okay? Now look over here. Everybody see this? Everybody see this sign? Everybody look up. Sleepyheads, look up. See this sign? Okay? I'm going to say this one time and one time only. It's not multiplication. Because it's what? It's open. It's a new symbol. It's basically a degree sign, is what it is. Okay? This means composition. All right? Just like the first set, you're going to see this more than you see this. This is the fancy speak. This is the useful talk. Okay? This is called a composition, and it does not mean fog of X. Do not say fog of X. It is f of g of x. Okay? Now, this translation right here, from here to here, helps you make this make sense. All right? Moving on. Using the functions f of x equals 2x minus 5 and g of x equals 4x, find each value. So we got 3 problems up here. We're going to find f of g of negative 2, g of f of 7, and f of 6. Okay? In that model, that was on the last slide. Okay, I'll even back up to it for you. There you go. We go into what function here first? The domain of what? G. Okay? Domain of G. And in this notation, G is basically on the inside, right? See that? Basically, the way you work these problems are inside out. No. Well, kind of, but still. So the first thing you're going to do is go to your innermost function letter. In this case, is G. Okay? You're going to do g of negative 2 first. And you're going to do that just like you always have. Okay? Which means you go to your g function up top, and you replace x with the number, which in this case is... Okay, the number you're replacing, though, is negative 2. There you go. Okay? So g of negative 2 is 4 times negative 2, which gives you negative 8. Okay? So g of negative 2, this red stuff right here, equals negative 8. Okay? Everybody with me? All right. Now, this g of negative 2, basically replace it with negative 8. Okay? And then so once you do that, you still need to run negative 8 through what? Through f. So now you find f of negative 8. You do it twice. Okay? You plug in the first number, you get an answer. You take that answer, you plug it into the next function outside of it.
Where does the negative and the y come? Where does the y come?
What y?
You said a block, really.
Domain and ranges, okay? So x, so technically speaking, negative 2, okay, technically speaking, negative 2 is in the domain of G. Negative 8 is in the range of G and the domain of F. Now we're going to take negative 8 that's in the domain of F, that we're plugging in, remember x's? And we're going to get a y out of it, a range out of F. Yes, there's a double, there's an overlap, basically. That middle number is your overlap. It's your connection between the two functions. Okay? If that doesn't make sense to you, that's okay, because it's pretty easy otherwise. So 2, just plug it in, just like normal functions. So 2 times negative 8 minus 5, which gives you negative 16 minus 5 to give you negative 21. And that's your final answer. That's what you want. Obviously, if it's an easy function like that, go ahead. Okay? They won't all be quick, easy functions like this. They'll just fix them. Okay? Ron?
Is it basically like that? Or it makes what
Yeah. You work them inside out, though. Okay? So if the letter order switches, like the first one had F and G, this one we have G and F. So this one we're going to start doing by doing f of 7 instead of g. Okay, it depends on what order these letters are in here. Okay, Jasmine?
But you got this here, you have to have like F being for outside.
Correct. That's totally interchangeable. Correct. Okay, so it's important to understand that you can just do these inside out. Start with your innermost letter and do that one first. So we're going to do f of 7 first on this one. Which is 2. That was an ugly 2. Try that again. There, much better. So f of 7 equals 9. Now you take 9 and you put it into g. Okay, so then you do g of 9, which is 4 times 9, which gives you 36. Okay? That's on purpose. Okay? On purpose. Good on those two? Alright, last one. F of 6. I gotta be careful when I say that. F of 6. So we're going to take f of 6 first. We're going to do it. So we're going to take it. We're going to double it and then subtract 5 from it. So 2 times 6. Whoops. Lift your finger. There you go. Good job, Mormon. You can write. Minus 5. 6 times 2 gives you 12. 12 minus 5 gives you 7. So this equals 7. Now you're going to take 7 and do what with it? Plug it back into f again. Okay, so f of 7 now equals 2 times 7 minus 5. 2 times 7 is 14. 14 minus 5? 9. Okay? Okay, 2 styles of these questions. One where you're doing numbers, like this. Okay, you're doing composites with numbers. If you start with numbers, you finish with numbers. Okay, so everybody understand what I'm saying by that? You start with numbers in here, you finish with numbers out here. Start with number, finish number. Start with number, finish number. Okay? Everybody good with that? The way this style gets harder is I make the functions more complicated. Getting some squares, some cubes, some negatives, stuff like that, but not above your pay grade. All right? It's just plugging in and evaluating. That's all that is. The second style looks harder from the onset, but once you get the notation down, it's kind of almost easier. Okay? So for this one, for each pair of functions, find f of g of x and g of f of x. If they exist, and chances are they will. Okay? So, remember what I said about the notation that's here. It's the fancy talk. It's not the helpful talk, though. To make it the helpful talk, change it to f, parenthesis, g, parenthesis, x, double close. All right? G, parenthesis, f, parenthesis, x, double close. Okay, everybody okay still? Okay, so they tell us that f of x equals 2x minus 5, and they tell us g of x equals 4x. The first one they want us to find is f of g of x. Okay? So, what's g of x? 4x, right? It says it right there. Look, g of x equals 4x. Anybody remember substitution? Yeah? Remember how that works? You know, y equals this, and we plug this in for y. Same concept. G of x equals this, so plug this in for g of x. So this goes in there. So f of 4x. which now looks like a question I asked you last chapter. See that? Okay. So now you take 4x and you plug it into where? Specifically, the function of x, replace x with 4x. That's where this gets just a little challenging. You have to keep it all x. Okay, since you are talking functions with just x's and y's. So these will be all x's, unlike last time where there were different letters.
So I asked you
Okay.
I asked you
Yes. Okay. So you started with a variable. You're going to finish with variables. Chances are, at least. Okay. Only thing you have to do here, operation-wise, is what? Multiply 2 and 4. Okay, which gives you 8x minus 5. Done. That's it. All right. So it looks complicated to start, but once you get that substitution notation down, it's not bad. Chamberlain.
You see them too. Oh, would you always put them in the parentheses like you did?
Yes, always. You'll see, and you'll definitely see why this next. No, actually, no, you won't. But anyways, yes, but definitely no. Okay, Ron.
So you basically just plug in.
You plugged in whatever g of x is, and you plugged it into f.
Alright,
So g of x is 4x, so I took 4x and I plugged it in here.
you got that.
Okay. Now going the other way, I'm going to take f of x, which is 2x minus 5, but instead of plugging g into f, this time you're going to plug f into g, because you work backwards. Okay? So g, let's change color. Blue. That was a terrible g. G of f of x. F of x is what? 2x minus 5. So we're going to do g of 2x minus 5 and plug that into g. And g is what? 4x. So we replace x this time with 2x minus 5. Okay, so see how they're different? Okay. Only thing you have to do here is what?
Oh, distribute.
Distribute. So 8x minus 20.
I can't do that.
Oh, hey, I didn't actually say it, but there's your homework. All right, page 389, 11 through 15, 30, 35, 45 to 48.